All right, so today is Unit 2, Day 2. Unit 2, Day 2. So we are in the middle of our transformation packet, and we learned yesterday a transformation is something that happens to a geometric figure where you can move it, change its position or orientation or size, right? Which one did we learn about yesterday? Reflections. So, we learned about reflections yesterday. And when I did a reflection, did it change the size? No, when we do a reflection, the size does not change. So there's a special name for transformations that don't change the size, and those are called isometries. And sometimes they're called rigid motions. These things mean the same thing. Isometries and rigid motions means the size does not change. And 3 of our 4 transformations do that. Reflections, translations, and rotations. Well, it's just information. Those 3 things all keep the same size. Okay? A dilation, when we learn about those tomorrow, those make things enlarge or they shrink. Okay, so dilations will change size. These 3 do not change their size. And we're going to have a benchmark coming up about the middle of the semester, so about where midterm would be. And that's something they'd like to add in there. Which one will keep the same size or whatever? And that would be anything that has to do with these 3. If it has a dilation in it, then it will not keep the same size. So we might see some problems later on that will get us ready for that when we review it. So that's why I want to go ahead and bring it up now while we're talking about it. All right, so let's talk about a translation. These are pretty simple. A translation is basically when you slide something. You don't turn it, you don't rotate it, you just take something and you slide it over. It's facing the same way, in the same direction. It doesn't get bigger or smaller, it's just slid from one place to another. You can slide something horizontally or vertical or both. So you can kind of slide them diagonally. So it's to vertically and or horizontally slide a figure. Okay, so this one is a quadrilateral and it is moved to the right and down side. You see that? Okay. It's still facing the same way. The short side is still on the top. The long side is still on the bottom. All right. So if we're talking about this in terms of variables, it looks like the ordered pair, x, y, is going to be x plus h, comma, y plus k. Now, back in Algebra 1, when we did things like vertex form and stuff like that, h was always talking about the horizontal direction and k was the vertical direction. Do y'all slightly remember vertex form? Okay, h was usually the horizontal change, k was usually the vertical change. So that's exactly what it is. H represents the horizontal shift. That's left and right. And K represents the vertical shift. So we're going to do a few translations. We're going to do example 1. So just like yesterday, the very first thing we want to do is graph the original figure. So this one gives us a rectangle, QRST. Please go ahead and graph those points and make that rectangle. Let's do that first. So we always want to start with graphing the original figure. And make sure that you label your vertices with those letters. And these are -8 to +8 again, so that might help you with your graphing. I messed up. My order was wrong. And obviously, when you finish, it should look like a rectangle. That's what it said it was. All right, when you finish drawing your rectangle, look up and see if yours looks like mine, because I have a tendency to miscount when I'm doing it on the screen for sure. All right, to me, translations, y'all, are very easy. Okay? It tells you right here what to do with your ordered pairs. Do you see that? So that means you take your x coordinate and add 5 to it, take your y coordinate and add 7. Does that make sense? Okay, so we're going to take the x coordinates and add 5 every time, and take the y coordinates and add 7 every time. So for example, for point Q, Q is the ordered pair, -6, -1. So I'm going to take -6 and add 5. What's -6 plus 5? -1. So that's Q prime's x value. And then I'm going to take the y, which is -1, and add 7. It's -1 plus 7. 6. Y'all see what I'm doing there? So you're going to take whatever this says, you add this to the x coordinate, this to the y coordinate. Sometimes it's subtracted, but these are both added. Okay? So for R, the x value is -3. What's -3 plus 5? +2. And then what is 1 plus 7? 8. So R prime is the 0.28. Okay? S is 1, -5. So what's 1 plus 5? What's -5 plus 7? 2. And then lastly, T is -2, -7. What's -2 plus 5? 3. What's -7 plus 7? 0. And then you graph your new rectangle and label it Q prime, R prime, S prime, T prime. So when you graph your new rectangle, it should look like you just took the original one and slid it over. Okay? You don't turn it, you don't flip it, you don't do anything, you just scoot it over. Now, one way you can check it is this is the horizontal shift, this is the vertical shift, right? And plus means right for horizontal, and plus means up for vertical, right? So for like Q, the Q prime, I should be going to the right 5 and up 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And on there. Okay? So that's how you check yourself. Does that make sense? Okay. All right, let's slide over and do number 2. Get it? Slide over translations. We're just sliding all over the place today. All right, so what do we need to do first on number 2, guys? Graph the triangle. All right, let's do it. I got to darken my arrows because I can't see squat. 2 -1. And I like triangles the best because they are less points. Less work. See if your triangle looks like mine. Make sure I didn't mess it up. Make sure you label your points. Or give me a thumbs up when you graph the original triangle. All right, good. So how do I get my new ordered pairs? Right, take your x values and subtract 3, take your y values and add 8. So the first point is C, 2, negative 1. So to get C prime, what is 2 minus 3? Negative 1. What is negative 1 plus 8? 7. So negative 1, 7 is C prime. You okay with that? Then D is 7, negative 4. So what is 7 minus 3? 4. What's negative 4 plus 8? Positive 4. And then E is 4, negative 6. So what is 4 minus 3? 1. And what is negative 6 plus 8? 2. And then we graph the next triangle. Label them. How do we check it? All right, so for X, I need to go where? Left 3, and for Y, I need to do what? Up 8. So if I go left 3 from 1, 2, 3, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. I hit 3 prime. Y'all see that? Okay. We're going to skip a few. Is that okay? Turn to page 5 and look at the top and look at number 7. So far, y'all think translations are pretty easy, right? Now, this one's a little backwards. What do you notice about number 7? Yeah, they did the 2 graphs, and we have to write what the rule said, right? We have to write what the rule said. Now, question, am I going from this triangle to this triangle or this triangle to this triangle? Yes. How do you know? Yeah, the one that have the apostrophes, the primes, are the final product, right? So you start with the ones that just have the single letters and no symbols. So for the rule, X, Y, arrow, X, something is happening to it, comma, Y, something is happening to it. Okay? So to go from D to D prime, do I go left or right? Right, so I'm going to be adding something. So the right is the positive direction, left is the negative direction. So I'll go to the right how many times? 1, 2, 3, 4, 5, 6, 7. And I'm lined up, right? So we're going to add 7 to X. All right, so I go across to the right 7. And do I go up or down? Up how many? 1, 2, 3, 4. So what do I put for Y? Plus 4. Y'all see that? And then you can check it with another point. So let's say for E, I should be able to go right 7, up 4 to get E prime. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. It works. Does that make sense? Okay, so just make sure you're doing the same letter, like A and A prime, X and X prime, all that stuff. Why don't y'all try number 8 real quick? It's easier to see on y'all's paper than it is on my screen for sure. So I'll start it. X, Y, X, comma, Y. Fill it in. I'm going to do P and P prime. Do 1 point, write the rule, and then check it with another point. It's probably the best bet. All right, I'm going to do P and P prime, right? This one's P prime and this one's P, right? So which one do I start with? P. So I start with P and I go to P prime. So if I'm going from P to P prime, do I go left or right? Left how many? 1, 2, 3, 4. So I'm going to take my X and do what? -4. Did everybody do that? And then after I go the left 4, do I go up or down? Up how many? 1, 2. So my Y value is going to be +2. And I'm going to check it with Q. Left 4, 1, 2, 3, 4. Up 2, 1, 2. I got Q prime. Raise your hand if you got those. So we understand how to write the rule. I like that. I think it's nice and quick, right? Not having to graph. All right, let's go down to number 9. Number 9 has 2 transformations they want us to do. Y'all see that? Okay, so let's go ahead and graph that original triangle. Let's graph the original triangle, please. Okay. Oops, I did not count over 3, Mrs. Wolf. You are crazy. All right, does y'all's triangle look like my triangle? Okay, do y'all see that we're going to do 2 things to it? We're going to reflect it in the x-axis and then do the translations. Now, didn't we learn about reflections yesterday? Right? And did we have a trick for reflecting in the x-axis? Something we can do with the coordinates? What was the trick? You can flip back. Very good. Change the sign on the y. Good job. So if reflecting in the x-axis, we change the signs on the y. So I'm not going to make you graph 3 different graphs on here, okay? We're just going to do the original and the final product. But I do want you to, like, maybe underneath these ordered pairs, write that ordered pair for the reflection. So we're going to keep the x's, change the y's. So that's going to be a -7. For point y, we keep -2 and change 1 to what? -1. I'm going to write that in there, change the y's. And then for z, -5, 2, I'm going to have what point? Good. So that took care of A part, reflecting it in the x-axis. That means you change the sign of the y's, right? We learned that yesterday. Now, we're going to take our new coordinates here and then do the translation, right? So what are we going to do to the x's now? Add 9 to our x. My blue x is up here. And what am I going to do to my y's? Add 2. Okay, so do the transformation in that order. So, I'm going to do these in red. What's -3 plus 9? 6. What's -7 plus 2? -5. So there's x prime. So for y prime, what's -2 plus 9? 7. What's -1 plus 2? -1 plus 2 is 1. Very good. And then -5 plus 9, 4. And -2 plus 2, 0. Y'all see what I did there? I just did the ordered pairs, so I didn't have to graph it 3 times. All right? Changed my y values, and then I did the translation. And now we're just going to graph our very final product. So write 6 down 5. Okay, so let's see kind of how we can kind of check it and see if our answer makes sense. All right. First, they wanted us to reflect it in the x-axis, and that was the x-axis I just highlighted yellow. So I reflected in the x-axis, that means I flipped it upside down like that. Does that make sense? Right? Flipped because maybe we counted the same spaces, and then I went to the right 9 and up 2. Does it look like I took this triangle, flipped it upside down, went right 9, up 2? I think so. Okay, so that's kind of how you can check it there. All right, let's do the next one real quick, and then we'll be done with translations for a minute. All right, let's go ahead and graph that original parallelogram, please. Give me a thumbs up when you have your parallelogram graph. Okay, so part A says to do a reflection in the line y equals x. So remember that line y equals x is the diagonal line that goes through the origin, and it has a positive slope, right? Right? So what was the trick for your coordinates when you had to reflect in the line y equals x? You swap your x and y. So I'm going to go ahead and do that to my coordinates. So if I swap q, I get -1, +2, right? If I do r, what do I get? 1, 7. S is going to be, and t is, right. So I'm going to write in parentheses there, swap x and y. Because that's what we did yesterday for reflections in the line y equals x. Now we're going to do what? How are we going to finish it? Yes, now I'm going to take my new x's and subtract 3 and my new y's and subtract 7. Does that make sense? So q prime, I'm going to start with q, which is -1, 2 now. What's -1 minus 3? And what's 2 minus 7? -5, good. And then I'm going to do r, which is 1, 7. What is 1 minus 3? And what is 7 minus 7? 0. And then for s, what's -2 minus 3? -5. And what is 6 minus 7? -1. And then for t, what is -4 minus 3? And what is 1 minus 7? -6. So any questions about how we got those coordinates? All right, let's graph it, and then we'll see if our answer makes sense. My line might be confusing, so I might erase it in just a minute. Yeah, that's right. I'm just going to move my Q prime. Mine's crooked. Y'all's look something like mine? Okay, so let's just think about it. I take my blue and I reflect it over that line, so it's going to be flipped up like this, right? And then I go left 3 and down 7. Does that look like that could be my... Yeah. So it kind of looks funny because I did 2 transformations, and then when you flip along that diagonal line, it kind of is funny. So just think about folding your paper across diagonally, this, left 3 and down 7. I should get close to where my red one is. All right, so any questions about translations? I hadn't finished transformations yet. All right, now let's do some rotations, please. Turn to page 8. So we're going to skip a little bit and turn to page 8. All right. Here's some stuff we're going to have to memorize. Now, a rotation is like I'm standing here facing you, and then I turn around and face the screen. Or I'm standing here facing you, and if I want to do a 90-degree rotation, I could turn and face the door. Does that make sense? Right? So I'm still the same shape and size, unfortunately. Right? I wish I could just sit here and turn in circles and get skinnier. That would be cool. All right? So I'm standing right here, still the same shape and size. I'm turning, that's a 90-degree rotation. If I turn all the way around, that's a what kind of rotation? 180. So if I keep going again, starting from where I started with, I did 270-degree rotation, right? Got it? Okay. So a rotation is a pivot. If you've ever played basketball, you know what a pivot is, right? Right? You plant one foot down, and you don't move that one because that's called traveling. Even though some refs don't like to call it traveling, especially if you watch college basketball and NBA, it makes me so mad. Right? Anyways, basketball's fun. I wish I was not too clumsy. I'd play it. All right. So the figure rotates at a specific angle and direction. So when you're pivoting, you're going around a circle. So we usually call those clockwise and counterclockwise rotation. Now, I don't have a regular clock. I have a digital clock. But y'all know what clockwise rotation means, right? The direction of the numbers of the clock. So 12, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Counterclockwise is backward, right? 12, 11, 10, 9, 8, 7, and that way. Okay? So that's what it means by clockwise and counterclockwise. If you memorize the degrees, that's really all you need to know. Okay? Because they're doing all of these counterclockwise, and they're making the pivot point the origin. Okay? So, let's memorize this. So this is going to be another one of those that you're going to do a trick with the coordinates. All right? So if you're doing a 90-degree rotation, you're going to take your coordinates, and you're going to swap the X and Y, and then you're going to change the sign of the original Y. So you're going to bring the Y to the front and change its sign. Okay? I'm probably going to write this on the board in a minute so I can keep it on where I can see it. All right? A 180-degree rotation is simple. You take your coordinate and you change both signs. That's it. Okay? So y'all know if I have a negative here, if it's already negative, you make it positive. That don't mean this is always negative. It means you change whatever sign it has. Okay? That means the opposite of that sign. And if you have a 270, you're kind of going to do the opposite of what you do with the 90. You're going to swap the X and Y. This time, you're going to change the sign of the original X. So I typically like the ones that have something to do that you can do with the coordinates. I'm going to write these down real quick so I can have them when we're doing examples. 93. Negative y x 180. Change both signs. 270. And you do need to memorize these. Okay? All right. So Did I do something wrong? I did. Y'all see it? I made them the same as they were. Okay. There you go. All right, so let's just do like one example of each, if that's okay with you guys. Because they're the same over and over and over. So number one, what's a triangle with what kind of rotation? A 90-degree rotation. So go ahead and graph your original triangle, please. That's what takes so long. Is graphing them. This is not mathematically challenging at all. It just takes a while to graph everything, and I will agree. B, and C is 4. And again, these are 8 by 8 grids, so that makes it a little easier to graph if you memorize that. But you're just going to 8 in both directions, so 6 would be 2 less than 8. And stuff like that. All right, so now we're going to do the coordinate game to get our new coordinates, and then we're going to graph the figure. All right, that's it. So for A is 2, 7. So for A prime, it says for a 90-degree rotation, I swap X and Y, and then change the sign of the original Y. So I'm going to change these signs. Right? So what do you think A prime is going to be? Negative 7, 2. Very good. What do you think B prime is going to be? 5, 6. And what do you think C prime is going to be? Negative 1, 4. That's it. And then you graph it, and then you're done. Okay? That's it. So left 7, left 2, A prime. B prime. C. So it's like you take your original figure and you do like a quarter turn. Does that make sense? A quarter turn. So you can kind of tilt your paper that way. Tilt your paper like this. And you can kind of see how it kind of maps onto it. Does that make sense? All right. Let's go across to number 2. What kind of rotation is number 2? A 180-degree rotation. So you got a square. I don't know why I'm doing this in red, but I am. I was kind of afraid it wasn't going to look like a square, but it does. Okay, so a 180-degree rotation is kind of like you take your whole piece of paper and turn it all the way upside down, right? So what do we do to our coordinates when we have a 180-degree rotation? Just change all the signs. So P prime from 2, 6 is going to change to what? Negative 2, negative 6. And these are all positive, so they're going to all be negative, right? Negative 6, negative 5, negative 5, negative 1, and then negative 1, negative 2. So left 2, 6, it's P prime, 6, 25, it's Q prime. R prime. S prime. That's it. Let's do one more, and then I'll let you do your practice. And I'm not even going to graph them. Is that okay with y'all? I trust that y'all can learn how to graph by now. I'm just want to do the coordinates for number 3. Is that okay with you guys? Okay. So what's the rule for a 270-degree rotation? Swap x and y and then change the original x, right? So I'm going to circle the one I'm changing. So what do you think J prime is going to be on number 3? Good. 4, -3. What's K prime going to be? What is L prime going to be? 1, -8. And M prime is going to be 1, -1. So any questions about that? And that's all. There's only 3 things it can do. Okay, and I showed you at least how to do the coordinates on all of them. So that's the end of Unit 2, Day 2.